All right, so this video is going to be specifically on point plotting. All right, and for this, we're going to use the multi-block 2 print. It's going to be drawing number 1222. See it here? All right. Now, what we're going to do here is we're going to take this block. This is one that, if you look, it's 925 thick, and the last part that we made was 1 inch thick. All right, so we're just going to take 75 thousandths off the top of that last one, which will clean up that and then some, and then we're going to have this part at 925 thick. All right. So the material, same material, 4x4 aluminum, all that good stuff. Same block you'll be using for all of these multi-use projects. So what we're going to do is we're going to walk around the outside of this block to cut that boss in there, and then we're going to come back and we're going to circular interpolate using G2s and G3s to cut this kind of donut out of the center here, and then we are going to punch in this bolt hole pattern. All right. It's not really a whole lot of point plotting that we need to do on this diameter here and this diameter here, but we are going to have point plotting on this. All right. Now, we're going to start with walking around this part, okay? And we're going to then do the bolt hole pattern. So the first thing we need to do is establish, where does G54 come from? Where are all of our coordinates coming from? That is one of the most crucial decisions that you're going to make, and it's something that you need to make. You need to make that decision correct right off the bat. All right. Now, when you look at this, to me, this part is just screaming center, center. All right. To me, this part is saying that all of our coordinates need to come off of the center, center. So dead center of the block. Not the back left corner, not back right, not front right, front left, none of that, dead center. And just to me, when we're looking at a block like this, we've got 5 decisions. I'm sorry, not 5 decisions. We've got 1 decision with 5 choices. We've either got back left, back right, front left. And I told you in the last video that I don't particularly care for coming off of the front, if you can ever avoid it. But to me, on this one, everything is coming off of the center. So you see you got this 2 inch here, 2 inch here. All right. This part, this print doesn't say it, but well, actually it shouldn't. But it's so everything is symmetrical. It's symmetrical about the x-axis. It's symmetrical about the y-axis. So this part is just screaming center, center. All right. Now, the really, really good thing about coming center, center, about coming from the center of the block, is you've got this Cartesian coordinate system like this right here. So if we put that center, we put that 0, 0 in the center of our block, all of our coordinates are going to be the same, except we're just going to change the signs. Okay. So with that being said, this point here, right here and here, that's going to be in quadrant 1. So our x is positive, y is positive. So these 2 points here, this point here and this point here, those points are going to both be positive. All right, down here in quadrant 4, we're looking at x is going to be positive and y is going to be negative. X positive, y negative. Quadrant 3, x negative, y negative. Quadrant 2, x negative, y positive. All right. So what I'm going to what I'm going to do here, I didn't do it in this print, but for all the ones that you're assigned, I'll have the points laid out. But the way I like doing it is start on this corner here. And that came from just kind of years of machining. And if your approach point, and I apologize for getting off on a little bit of a tangent, but I'll kind of give you a little bit of thought process behind this. But if my approach point was back here or back here, somewhere on the back, and my tool is coming down, then you're going to have a little bit more trouble seeing it, right, with it being behind your block and everything else. So you're, a lot of times with machining, we're checking clearances constantly. So if it's up here on the front, you'll be able to watch and make sure your tool's not going to hit anything that it's not supposed to. So that's one of the reasons that I picked that's going to be 0.1. All right. So let's talk about that 0.1 real quick. And I tell you what, I'm gonna pause and get Notepad pulled up. All right, so now I've got Notepad pulled up where we can kind of jot the points down. All right, so let's find the X value for 0.1. All right, so if you look, it's 3.75 across that boss. All right, so half of that is going to be 1.875. All right, you can punch that in your calculator, but half of 3.75 is 1.875. So from the center over to that edge is 1.875. Now, we're not talking about that edge though, we're talking about the beginning of that radius. And that radius is 250 thousandths. So if we do 1.875, so from here to here, minus that radius, 250, then that's going to give us 1.625. So our X is going to be negative 1.625. All right. Now, our Y is also going to be negative because we are in the negative quadrant. So that is going to be, again, this block is symmetrical any way you look at it. Symmetrical X, symmetrical Y. So 3.75, again, half of that 1.875. So from the center of that block to right here is 1.875. So that's my point. All right. So for 0.2 going up here, so we're still going to be in the negative quadrant. So we know both X and Y are going to be negative. So we know that our X, again, from the center of the block over to here, is going to be 1.875, which is half of that. Well, all right, so then our Y is going to be from here. If you come all the way down to here, that's negative 1.875. Then you have to come back up for that radius. You see how that's 4x. So it is going to be 1.875 minus 0.25. So that's going to be 1.625. All right. Now, here comes the beautiful part of center, is we've got our key numbers here, and all the radii are the same, all the points are the same, everything's symmetrical. So now we pretty much just start plugging and chugging here. So this one, again, this is quadrant 2, so X is negative, Y is positive. So X negative, Y is going to be positive. Now our 0.4, which is going to be here, that's going to be x negative and y positive. So from here, so looking at 0.3, looking right here. So our x is going to be 1.875. Same reasoning as we had before, half of that 3.75. And y is going to be positive 1.625. So from here to here is 1.875 minus 250. Put us right there. All right. So 0.4 here, that's going to be x negative 1.625. Same reasoning. Y is going to be 1.875. All right. So for 0.5, now we're talking over here. That's going to be in our positive quadrant. And of course, 0.6 is going to be positive as well. All right. So up here, our x is going to be 1.625. Our y is going to be positive 1.875. We're talking here now. All right. Now to this point here, which is going to be 0.6, our x is going to be 1.875. And our y is going to be 1.625. All right, so 0.7, which is going to be right here. Our x is going to be 1.875 positive. Our y is going to be negative 1.625. And for 0.8, which is right here, we are at x 1.625 and y negative 1.875. So that should be all of our points for walking around this boss. Now, if you were doing this from a corner, like we did in the last video, all right, then all of your points are going to be totally different. And to me, it gets a little more confusing when you're working with 8 pairs of totally different numbers. But for here, you look and you see that it's just it's a process. You just remember this, quadrant 1, 2, 3, and 4, and then you find those values, and it's basically just repeated over and over and over. All right, so that should cover you on that. The next thing I'm going to do is show you the bolt hole pattern. All right, and I've got some stuff drawn up for that. I'm going to pause it here. You're not going to see a pause, but I'm going to pause it for my sake and get all that pulled up, and we'll talk about that next. All right, so now we're going to talk about this bolt hole pattern, this bolt circle here. All right, and we're going to use a 1/4-inch end mill, just like a drill, to come in here and pop these holes in. Pretty straightforward process. Now we're also going to benefit from this being in the center, our G54 being in the center here as well, all right, because that's going to ease our math a good bit. All right, because again, we're going to be following this same principle here with the different quadrants, to where really what we need to find is this point, and this point, and then we're just going to repeat it all over again. All right, so this trig sheet, this is a trig sheet that I use, and I'll make sure that you guys have a PDF of this. I'm going to make myself a note here. All right, so I'm going to make sure you guys have this, and we're going to be referencing this a good bit, throughout this. All right, so when we look at this, you see that it's 10 holes here, and they are on an 1.25" bolt circle. Now, we're not really concerned about any of this stuff right here, right now. That's going to come in the program. We're more concerned about the XY positions, right? So I drew this up to kind of show you, and I just simply drew a bolt circle here. You see it's an 1.25" in diameter, and drew those at 1/4 inch. Don't really matter, but if you count those, you're going to see that that is 10 circles, 10 holes in this bolt circle. All right. Now I just extruded them up. Not that that's really necessary, but it would just help me sketch a little bit. All right. So when we look at this, we need the X coordinate for this hole. So this is going to be our first hole here. All right. And most of the time when you do bolt hole circles, whatever hole is at 3 o'clock is going to be your first hole. All right. That's just kind of how it goes. Not going to really try to explain it or anything, but that's just kind of how machinists normally do it. Right. So basically what we need to do, give me a second, let me edit this sketch. So what we're going to do is we need to know this distance. All right, there is no y. Our y is going to be 0. And just going to say that's at 3 o'clock. So our x and our y. So our y is going to be 0. Pretty straightforward. All right. Now our x is going to be whatever the radius of the bolt circle is. All right. So if I do this, if I measure from here to here, you see that's an 1.25". That's the bolt hole diameter. All right. But really what I'm concerned about is the length of this, which as you can see is 0.625, which if we go back to this, that 1.25 bolt circle, .625. All right, so going back to fusion here, so you see we need to move from the 0 positive 0.625 to that location. So our x is going to be positive 0.625. All right. Now, the next thing we need to figure out is, I'm going to delete this, and we need to figure out the x coordinate and the y coordinate. So x is going to be here, y is going to be here. So I'm going to just draw a line. All right. So this is the triangle that we're going to try to figure out. Now, let me go ahead and state the obvious. I could just inspect these lines. I could just measure these lines and they would give me the correct value if this is drawn correctly. But it's not what we're doing here. We're working on Trig. So wherever you go to work, we don't know if you're going to have CAD software like this. We don't know if you're going to have access to the internet so you can use calculators, all that stuff. You need to know how to do this with a calculator. All right. So we need to figure out a couple things, all right? For one, we need to figure out what this hypotenuse is, all right? Now, I'm going to go ahead and inspect that one and show you that, try to anyway. So that line is going to be 625. So every triangle that we draw, so if there's a line coming from the center to the center of the hole, that line is going to be 0.625. That's just how a bolt circle works. All right. Now, what we're after here is this value and this value. All right. So we need to figure out an angle. We know this is 90 degrees. We know that these two circles or lines right here are perpendicular. They won't even let me put that constraint on there, all right, because this is horizontal and this is vertical. All right, so we know that's 90 degrees, and if we figure out one of these angles, we'll be able to figure out the other, all right, because all triangles add up to 100, all angles and triangles add up to 180 degrees. Now, this is extremely simple, all right? If you count the holes in this pattern, you're going to get 10, all right? Going back to the print, all right, 10 circles, 10 holes. So if you take 10 and divide that by 360, so I feel kind of crazy using a calculator for this, but 10 divided by 360, I'm sorry, 360 divided by 10, I can't be the only person in the world that gets those mixed up. 36, right? So going back here, if I inspect from here to here, see, I've got 36 degrees, which means this angle here is going to be 54, which is 90 minus 36. 54. All right. So now we need to start thinking about our triangle. So if we go back to our Trig cheat sheet right here. So in our triangle, our C is going to be 0.625. Our A is going to be 36. Our B is going to be 54. Now, if I was you, I would go ahead and jot those down. You know, I don't necessarily want to do like a webcam and show you a dry erase board because it never comes in clear. But if I was you guys, I would jot that down. All right, I would draw that triangle and fill in what you know. All right, so I know that we need to find A and B. All right, those are our unknowns. So we've got everything else. So if we're finding A, then we're going to use this column here. We're going to use these functions here. Now we're just going to pick one that we can fill out. All right. So let me just start by showing you one that we cannot fill out. So this one here, A equals B divided by the tangent of B. So we know big B. We know that angle is 54. But little b we do not know yet. The same with this one here. We know big A, but we do not know little b yet. All right, so we need to use one of these. All right, so let's just go with A equals C times the sine of A. So what that's going to look like is A equals 0.625 times the sine of 36. All right, so I'm going to go 36 sine times 0.625. All right, so that value, I'm going to write that down, is 0.3674. All right, and I said 3674 because I rounded up. That 6 rounds that to a 4, so 0.3674. All right, now it's important to note that no matter what we do, we're dealing with a rounded number here. Okay, so we want to use solid, like full numbers whenever possible, whenever we're doing trig calculations. All right, and I'll get more into that here in a second. All right, so that number 0.3674. I'm going to go over to back to here. All right, so what we just found was little a over here. So we found that's going to be our y. So what I'm going to do is inspect here. .3674. All right, so that is correct. And I'm using Fusion to just kind of illustrate this to you guys. All right, so that number, that 0.3674, that's going to be our y. So our x we don't know yet, but our y is going to be positive 0.3674. All right, so let's work on the x. Now we need to find b. All right, now we need to find b. So b equals c times the cosine of a. We can use that. We've got all those values. Now, a couple of minutes ago, I said that we want to use full values whenever possible. All right. Now, we could technically use this. And for all practical purposes, that would be absolutely fine. But if we use a, unless we use this full value that I'm sure goes off into infinity, all right, then our number is not going to be like 100% accurate. Now, going back to what I said, 99.99999% of the time, it doesn't matter, all right? But just speaking in generalities here, there is a better choice, all right? We can use B equals C, which we know definitely is 0.625, times the cosine of A, and A is 36, all right? So come back over here. We're going to go 36 cosine times 0.625, so 0.5056. Writing that down. I'm going to come back over here to Fusion. That's going to be our x value, 0.5056. Right, and all those are positive because we're in that quadrant. All right, so 3 is going to be, get this set up first. All right, so let me delete some of this, redraw us a triangle here. All right, so that's what our triangle is going to look like. And you can draw this a couple of different ways. You can draw it that way. You can draw it with the triangle going up like this. You can draw it however you want to draw it. Doesn't really matter. The result should be the same. All right, let me just make sure my sketch is good here. Yep. All right. So we know that this line here is 0.625. All right, because again, that is the hypotenuse. So we know that's 0.625. All right. Now, in this case, this angle here is no longer 36. This angle is going to be double that, because from horizontal, a 36-degree line is here. We're double that. So now we are going to be at 72. All right. So if we go back to our trig sheet, our big B is going to be 72. Okay. And then I hate doing this, but 90 minus 72, 18. All right. So our little a is going to be 18. And our big B is going to be 72. All right. So if we do the same formulas, all right, if we do A equals C times the sine of A. So we're going to be the sine of 18. So 18 sine times 0.625. So 0.1931. So going back to here. So 0.1931. That is going to be our X. Because again, we found little a. And if you look at that triangle, that right there should be 193 thousandths and a tenth. So let's check it. 193 thousandths and a tenth. So we're good there. So go to Notepad. That X is going to be 0.1931. So now we need to find Y. Going back to our trig sheet. Now we need to find little b. So same formula here. B equals C times the cosine of A. We'll clear that out. So A, go back to that. Yeah, A was our 18. So 18, this time we're using cosine, times 0.625, 594 and 4/10. So 594 and 4/10, that's going to be in our Y. So going back to here, it's going to be 0.5944. Right? So I know that that was a lot of legwork to get to those. All right. And I know that you guys are not going to, be able to use Fusion to draw this out and get these values, especially, depending on where you go to work. But hopefully it helped illustrate that. All right, but we're not done yet. Still got a handful more points to do. And I am fat fingering every key I type tonight. All right, so here's where it gets easy though. All right, so this triangle here, like, so if we basically we're duplicating. All right, so let me draw real quick the first triangle that we had. All right, so that was our first triangle that we figured out. This was 36, all that stuff. We figured that out. Now, I'm going to draw a line here, draw a line here, I'm just going to mirror this to show you. All right, so it is the exact same on the other side. All right, all I did was just mirrored. Okay. See? All I did was mirrored and it lines up perfectly. So all we've got to do to find, so we had 1, 2, 3, 4, to find hole 4 is we need to go back here, and our x is going to be the same but negative. And our y is going to be the exact same. And for 0.5, that's going to be the same as 2 here. I'm actually, well, not going to do that just yet. So our x is going to be negative 0.5056, and our y is going to be positive 0.3674. And then, of course, for 0.6, our x is going to be negative 0.625, and our y is going to be 0. All right. Now, I'm sure you know where the rest of this is headed, because everything else is the same. "23 selected." Let me do that. All right. Sorry. That fixed. All right. So now all I did was just mirrored that right around. All right. As you could have guessed, those points are going to be the same. We just have to change some signs. All right, so let's pull this up. So tell you what I'm going to do. Go 5. Let me pause it and figure this thing out real quick. Give me a second. All right, so our 0.7. So 1, 2, 3, 4, 5, 6, 7. So that 7 is going to have the same x and y as hole 5. 1, 2, 3, 4, 5, except different signs. All right, so 5 is negative 0.5056. All right, still in the left hand of the origin, so it's still negative, and y is going to be negative 0.3674. All right, 0.8 is going to be the same as 0.4, so whole or 0.8 here is going to be the same as this one. So that's going to be x negative 0.1913, and y is going to be negative 0.5944. Okay, so 9 is going to be the same as 8 and 3. So it's going to be positive 0.1913 and then negative 0.5944. And 10 is going to be the same as 2. So x is going to be 0.5056. And y is going to be negative 0.3674. All right, I know that's a long way around to find those points. Hopefully you were able to stick with me through that. Hopefully it wasn't too boring. But there's the points for this one. All right, hopefully you picked up a little bit on it. But again, this cheat sheet, huge. Absolutely. I mean, this is a great document to keep around. I keep one in my toolbox. I keep one in my bag. Everything. I keep one everywhere, and I end up referencing it a whole lot. All right. So we've got the points here. We plotted those out. Well, first off, we picked that we were going 0, 0 in the center. We plotted all these points with this being point 1, 2, 3, 4, walking all the way around it. Because again, we want to climb mill this whole deal. All right, and then we plotted all of these points here starting from 3 o'clock, then going counterclockwise. So this is hole 1. This is going to be hole 10. And the one that I have you guys do, it's going to be the drawing 1222.2. All right, I'll have all that stuff labeled for you. All right, but hopefully this helped. As always, you got any questions, critiques, concerns, anything like that, just shoot me an email, call me, whatever you want to do, and we'll get it figured out. All right.